Hi, today we will talk about the chain of responsibility. The goal is to be able to recognize the code smell and apply the transformation. You will find a lot of pattern explanation over internet. This is quite nice. Sometimes you have this kind of code, you can transform it to that. Okay. Here the basic is to try to see the smell and then apply the transformation and go over with it. So, what smell we can encounter? You have a lot of if then else switch cases. You have a flow in which you want to do something with a first actor, and then if this cannot fulfill the action, then he move the request to the other one. You want to have a more flexible code, having a way to add, change, or easily remove an actor on the fly, or just defining a different set of actors for a particular context in your app. You can define rules for one unit and using the same kind of rule for another one unit, but you want to be able to play with them. So the pattern chain of responsibility is for you. You will find a lot of examples, like I said, over internet about pros and cons. Okay, it's not you go ahead blind with this pattern. You have to study a little bit. Basically, first I will show you the first try I did with the first implementation I did with the chain of responsibility, which is like a backward way. You start like with the command pattern, and I will show you how you can chain it. And in another video, not in this one, probably in another one, I will show you how you can do it in forward way. You can see the example in Code Guru, or you will see it by having next handler. You have to expose a method that you will be able to add the next handler. At some point, yes, it will work. It's like a proxy, but yes. The benefits. You will respect some solid principle. You will see here that we will be able to use open source principle. Then you will be able to change on the fly command or actors. We will be able to extend it. You will be able to add decorator if you want. You will respect the SRP, the single responsibility principle, which leads to have one single class having one single responsibility, easy code, easy to test. Like I said, simple code, more flexible. Yes, there are some drawbacks. Yes, if you really want some performance, you will have to choose. Probably this pattern will all add a little overhead, but let's go with defining what is your goal. If you are doing business need with customer that change ideas every day, probably you will prefer having compression over complexity, and you will prefer more flexible code. If you want to do gaming, which performance is the main goal, probably this pattern is not suitable for that. You want parsing an image or data over a high volume, probably this pattern won't fit, but you can sometimes use the chain of responsibility in parallel mode. So this is a quite exploring that pattern will give you some more idea. Like I said here, pattern always depend on your context. Keep in mind that sometimes you will prefer understandability over complexity, okay? Depending on your context and your business. If you have a lot of juniors, you will probably prefer understandability because you will try to minimize the learning curve, and you will gain over time. If you do complex code, no one will be able to change your code, and they will just do something else. Okay, you want your code to live much more longer time. There are some examples that you always use, like chain of responsibility. At some point you can have like the filters, like authorization and authentication. You do a post request, and then you have many filters to apply. You have like a call center, like level 1, level 2, you call one person, they cannot under your call, they will move you to the level 2. You have like, you want to do something with number, if it's less than 10, if it's equal to 10, it's upper to 10. You want like a validation of your expense report. It's less than $10, then Jack can do it. It's less than $50, then Margaret can do it. It's less than $100, then Julia can do it. Oh, I think here, if it's more. Bref. Through classification or filtering or categorizing, by example, you want to separate apple, pear, and orange. You want to exclude rotten fruit. You want to classify them by size. You want to do some dispatching or parsing, like by example in ATM machine, you want to dispatch $1, $2, or separate it in each bucket. You want to parse or evaluate a ping or a GIF image or PNG. By example, a classic one that you will find is the poker game. You want to determine for a set of cards, if it's a full, if it's a straight, if it's a 4 of a kind of, like in a poker, you have many kind of set that you can have. You want to apply a set of rules. You want to do strategy selection. This is one way that you can apply. You want to parse or filter or reduce XML. You want to use logging to multiple contexts, like you want to at the same time you want to be able to email, file, or console. There's many possibilities. You just chain them, then it will propagate the information. You want to ask for vacation, you first ask your colleague, then you ask your team, then your manager, then the RH. So there's a lot of possibilities. Opening here is, like I said, you have to recognize when you can apply this pattern. Basically, you will have something like this. In a loop, you will have, if some rule, then do cool stuff. In some other rule, you will do some other cool stuff. And so like this. You can transform that pattern, that smell, into some pattern like this. I get the chain of responsibility from Code Guru, then this is the first if, the second, the third, and then you can propagate the information. Also, this will lead you to the state machine, because if you look at here, you cannot, it's just OK or N. OK or N. At some point, you should be able, okay, I have a predicate, then if I'm at state 1 of a predicate, I can go at state 2, which is not able to do it here, but it's almost a state machine, a chain of responsibility more complex. This picture was taken from Stack Overflow at flowchart state machine. So the goal, like I said, is to recognize that you have something like this, like a cut smell, and then you want to extract them to small class respecting OCP and solid principle like single responsibility, and then you want to have more flexible code. Keep watching, we will go over a small example. Thank you. Hi, welcome to the chain of responsibility demo. I'll take the example from a request that you can receive from the web. Then first you will have to know if you are authenticated, then if you are authorized, and my example is the user has access to write, is granted to write. Okay, basically what you can have is something that you will have a class. Okay, let's say we will call it can continue. Okay, just to have name. Then in which you will have a method that is to evaluate some requests. Okay, first what you will have, it's probably you will have some kind of requests with parameter which contain is authenticated. Then okay, you evaluate if it's authenticated, Then if it's yes, you will want to know if it's authorized. It's basically the authorization pipeline. Then if it's authorized, you will continue. And then you want to know if the user is allowed to write, by example. Then you will get the user from the request or from a repository. This remind on you. And then you will ask if it's granted. Here I just do some simple code just to if it's granted, then you print yes, I'm authenticated, authorized, and I can write, and you will return true. Oops. You will return true. Okay, and that's it. But at the end, if something fails, you have to return false at any point. Okay, you agree with me? Then you create an instance of the class if you can continue. Then you create a user. At this point, we'll just put it is write granted true, just to be able. And then we will create a request which has the authenticated true and authorized to true and the user in the request. And after this you evaluate the request with the instance of can continue and you print the result. Okay, basically you will have that kind of code somewhere and you can transform it to some chain of responsibility. Let's run it. Okay, yes, you are authenticated, you are authorized, and the user can write that I'm authenticated, authorized, and I can write, can continue, is true. Let's move on. Okay, we look at that and maybe we can do some refactor. Okay, it's the first step of thing. Then at some point is like we can refactor to have one layer instead of going into nested if, and nested if. We can turn it to exit as fast as you can from a series of if like this. We can just revert the if and said okay, then if request fail, return false. Okay, and then we just move down one layer. We apply the same pattern here. Okay, return false. If you look at this, I have no goal to continue if you are not authenticated. Exit. Exit. You are not authorized. Exit. Okay, then we can remove this. This pattern is quite nice. Sometimes it will show you some behavior, because you will see, oh, there's something here, there's something here. Let's continue. Okay, the same thing here. Return false. Okay, then at the end we have to return true, but in Ruby we can just keep it to true. Okay, is this code will work? Okay, so back, we just do some refactoring, we run, and yes, I haven't break anything. And then you can do some refactoring, return false. Okay, again, because we are in Ruby. Okay, we can move it, reduce some complexity. Then, is this will work again? Yes. Okay, at some point we just try to refactor some part of the code. Okay, at some point you will say, yes, but why I will move that to chain of responsibility? Okay, I'm agree with you, it's a small example, but keep watching. You will see that at some point you will have not just 3 commands or 3 action, you can have 10 or 12 action. Then it will be useful at this point. So just coming back here, you can see that you have one action here, you have one action here, and then you have one action here. Okay, let's write some command from all of those actions. Okay, basically you can use like a cool naming, like I have a class is authenticated command. Yes, it's more like a predicate. You can also try to use the predicate or the action instead of command. It remains on you. Sometimes you will probably sometime find that this is a command and you will try to find a better naming, but let's go with it. We have in a command, we have a command execute, okay, which will receive the request, and what we will need in here, we just put that line here, and because it's Ruby, we can have, you can do this. At some point we can also do like this. Okay, I just keep it like this way because you will see a better example. If I want to do the same thing with authorize, I take this line and I put it there. I just add the true, and for the is the user right granted command is available, the same thing. I will take that part and I will move it there. That's fine. Okay, this is part of a refactoring. First refactoring is move code as is. Don't change anything. You run your spec, and then you can prove that you have not broke anything. But yes, I made some command. Okay, I have to use it there. Let's go with it. Okay, return false if is authenticated. Okay, I have to put it there, new, the execute, and then you put the request here. Okay, that's fine. I just changed the hard stuff here to much more self-explained class with my code. Okay, and here the same thing. Boom. Yeah. What you can see here is, okay, I don't care how it's implemented, authenticated, or authorized, or is user right granted. Here, I want to know if I can continue. Okay, I will ask something to know about this. I will ask something to know about this. I will ask something to know about this. How it's implemented, here, it doesn't matter. Okay? You can, it's why it's at some point where you can use classes to defer implementation to something else, and then you will be able to change the authentication process easily. Okay, you just have to push a request, and here you can inject anything, you can do what you want. You just have to respect the contract. Okay, let's move on. Is this work? Yes, I have not changed anything. Okay, you have now a more verbose code and a self-documented one. Okay, you can see that, oh, okay, is user right grant command change? Okay, I go in that class, and then I'm able to change the code. I want to extend or do open close principle, or even change that command to something else. No matter, I just came here, I can create a version 2, I came here, I set the version 2, I just have to respect the contract, and that it's done. So next, okay, this is not a chain, it's just a way to just write code more in a cool fashion. How we can chain it. Okay, I said in my introduction that we will use a backward reverse implementation. For doing this is that the command must know which command to call if the call here, the request has failed. Then what is true? Then if it's true, then you call the next one, the next actor. If it's true, then you call the next actor. Then following this, the first pattern you will see probably in the old school, from old time, is to inject the command, to pass the command in the cross structure. Then you can see that for the authenticated command, I have to push the next command, because after I'm authenticated, I have to know if I'm authorized. And if I'm authorized, the same thing, I have to know if I'm trying to do something. A quick shot here, I removed the initializer of the next command for the user write. But if you look at some state machine pattern, you always have a start point and an end point. That at some point you should have a null command at the end that do nothing in order to have a more structure, same way, a same pattern that you can replicate everywhere. Because here you have one kind of those command is similar, but this one is different. Then if you want to reuse it somewhere else, you get stuck because this one doesn't have a constructor. Then in order to do that, you have to add a fake command, a null command that is the endpoint, which do nothing. At some point we can do it. Okay, let's see we will do it. It will be fine. Class null and command. Okay, and this one will have also the execute. Okay, that's it. And return true. Okay, it's just a null command. And for doing this, I will have to push the next command. This won't break anything because if this one fail, it won't call the next one. If this one success, if the user is grant, then it will call this one, and this one is just a null one, but it will allow this one to be reusable everywhere. Okay, that's fine. Let's go with this. Like I said, it's I have to make it in a reverse one. Okay. To save us some time here, I just wrote it down here. Okay, just save time. Okay, is user, but in my example on the fly, I just inserted the added the null command. Then I will just have to add the null command here. That new. Okay. Then this one is a null command. And I will have to inject into that one. Okay? Then, like I said, it's in a reverse. Then I have to declare to create an authenticate command, which will call the authorize. The authorize will call isUserGrant. The isUserGranted will call the nil end command, and the nil end command return true. So instead of having the true false here, I can move to just have something like this, return false. Okay, you also can have a builder for that. Instead of having all of those class here, you can just have something that inject the chain directly in the code. And let's try. Yeah, it works. You're not convinced? Let's add some debug to see. Okay, I'm executing this one, I'm executing this one, I'm executing this one, and I'm executing this one. Okay, let's try again. We will see some printing on the screen. Oh yes, my bad. It just called the first one because I forgot to call the next command. I just instantiate just inject the command, but I forgot to call it. Okay, that's fine. I just have to use the command here, bing.execute request. This is the pattern of command. Okay, you should have the same naming, the same signature in order to push the request downstream. Okay. Then you go here, bing, and then you go here, bing. Okay, you should have the same pattern. And also you can use the params. If you have a code smell that you have a signature with a lot of code, then you can inject, you can pass a parameter here, which have a much more information in it in order to simplify the signature. And this one, it's return true. Okay, let's try it again. Yay! And then you can see that I'm authenticating, I'm authorizing, I'm checking the grant, the user write grant, and then I end my pattern. Okay, like I said here, you can have a builder that create that command outside, and you just have like give me that you have a factory or a builder, give me that chain for that pattern, for that context, and then you will get rid of this construction. Okay, but if you can continue, you just have to call can continue chain, and then you will pass the execute, and then this has been done before. For the last part, I'll just show you. Okay, here I have one request. I can get rid of this part. I will just keep the instance of, and then I will create 3 requests just to show that it can work with many requests. Then one is authenticated and not the third one, and then it's grant but not the other one, and something like this. I have 3 requests. Then I can just move it to some age, and then I can execute each request, and then I will call can continue, which I have instantiated before, and then I save some time because I didn't do new everywhere. The same thing here. If I will create 4 new each time, then I can inject my chain in this, because this is at some point stateless. Then I will save some instantiator. Then with this, garbage collector will be less used. I will stop making a lot of usage memory. A lot of things that can be helpful here to use chain of responsibility. Okay, you build it once, and then when you have the instance, you can play with the instance. Okay, and I have 3 requests. The first one will be false because you are not granted. The second one will be false because you are not authorized, and the third one will be false because you are not authenticated. Okay, let's run. Okay, we can see here that the first one return false because the user probably is not granted. The second one, like I said, it will try to authenticate, yes, and authorization fail, then fall. And then the third one is not authenticated, then it won't continue. Like I said, it's fail fast, exit as fast as you can. Then it won't ask the system or overload the system for asking if it's authorized. No, you are not authenticated. Exit, quit. You can continue. Exit there. This is that kind of pattern. At some point, you will use the other way. You are not. You have to send the first request to someone, but someone is not allowed or hasn't much right to execute the command. Then you will send it to the next one, like a call center. The level 1 is unable to handle your request, then it will ask the level 2 to do it, and if the level 2 is not able, it will call the level 3. Then it's different kind of playing with the chain of responsibility. So that's it, dude. You have seen a way to detect a code smell and how to transform it and apply the chain of responsibility pattern using some design pattern, also like the command, or this is like a strategy, and then you chain it, and then you execute it, and then you save time overall. Thank you for watching.